Hello everyone, the Instant Camera Guy here, and welcome to what will be part 1 of, hopefully, tearing down and repairing the Polanthropy Alpha M. As I demonstrated in the last video, this is a new manual control SX-70, invented by Dan Huey of Polanthropy. This one, unfortunately, is dead on arrival. If you want to know all the issues that it had, please go and watch the previous video that I did. But yeah, basically, as cool as the features are on this camera with manual control and a little display with buttons that you can press, this camera does not function. All of the photos that it takes are completely washed out and overexposed. Again, examples in the previous video that I did. And I have blessing from the client of mine that owns this, that I have full reign to take this thing apart and try and repair it. So today's video is really going to be an autopsy of sorts. I believe I know what's wrong with the shutter. I believe the solenoid is completely out of calibration. I have already dropped the shutter forwards to have a peek underneath, and the soldering job on it isn't amazing. So whenever I see something like that, I can only assume that probably other things inside the camera have been missed, so I will be fully taking this thing apart and overhauling it before I even attempt to correct the shutter and do anything else. The other thing that I need to experiment with here is the camera. My client wants it to be PolaVolt modified. So the little... what's the word I'm looking for? Little battery pack with a buck converter and AAA sized 10440 cells that goes at the back of the camera that I invented. My client would like me to install that so that they can use I-type film on this camera. I don't know if it's going to be possible to PolaVolt mod this though, because the shutter has this interesting dark slide eject that I demonstrated in the last video. So it has automatic dark slide eject with a double tap of the shutters to indicate that it is currently set for 640 ISO. Now what I need to figure out is, can I disable that automatic dark slide eject, or is it hard-coded into the firmware? Because if it's hard-coded into the firmware to sort of sense that, you know, every time the pack of film gets like powered, it's going to do an automatic eject, well then we're kind of screwed. Because... effectively, I need that dark slide eject to be disabled for the PolaVolt to work properly. As I explained in the last video, when it comes to I-type adapting cameras, you really don't want automatic eject because the camera just simply isn't designed to be powered by external batteries without there being a pack of film in there. And so what that means is if you were to accidentally leave the thing powered on with no film inside, it's going to cycle the motor continuously, it's going to close the shutter blades, which might burn out the solenoid, yada 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 yada. So I need to figure out, first of all, can we disable that? Once I've figured that out, that yes, we can disable that, well then I will start to do the rest of the repairs and that kind of thing. So, first thing I'm going to do, and as I said, I do want to do a proper review of this thing and talk about some of my thoughts. In the last video, I talked about why I think double exposures on this camera are a bit of a problem. I'm not going to explain that here. Today is really just going to be an autopsy. I will explain that in future videos, but I want to get this thing working first, or at least taken apart to see if it can be salvaged. Now this leather that's on the camera, I don't think I'm going to reuse. So I am just going to peel it off. This is not a particularly easy leather to remove. All right. And that gives me access to the bottom panels. Now there is some adhesive still here. I will be cleaning that up a little bit later. But yeah, so I'd like to remind everyone that the purpose of this video is not to trash the previous technician that worked on the camera. It is meant to be of educational value to anyone watching. Because the state that this camera is in, I can really only see two scenarios. The first scenario is that the camera was mistakenly sent out to a client before being actually ready. Like, there is a possibility that this thing was just kind of tacked together tested basic functions. They needed to do more servicing stuff at a later date, but they forgot, or it got put then into the wrong pile, reskinned and sent out to the client before it was even tested and working. The second alternative to this, and I'll just turn the camera around because the, the bright lights really trick the auto exposure on my camera. The second possibility is that this particular technician that assembled this camera just doesn't have the skills yet. Not to say that they can't learn, but at the moment they lack what I would consider adequate skills to properly refurbish one of these things. And they have assumed that if they just stick a new PCB and a few bits of fancy technology that they're going to end up with a working camera, when I think I've demonstrated enough times on this channel that is certainly not the case. You really do need to overhaul one of these things properly, fix all the different preemptive parts that can fail if you're going to expect one of these things to work at its very best. So either way, whatever the actual issue, my video here aims to educate. All right, so a few things that I'm noticing. There's certainly Kapton tape everywhere, indicating that they've insulated the camera. Now, I'm probably going to take some photos on my phone as well. I'll let you guys decide who is better at soldering. But what I will say is I am certainly more skilled than this. The quality of soldering here is really not fantastic. There's also some damage to the ribbon cables here as well. Like, I wonder if this ribbon cable at some stage has been replaced. I also see that they've scraped away some of the trace here that goes towards the motor. So underneath this piece of Kapton tape, can you guys see that copper? There's some, it's like they've removed some of that top layer. Now, I wonder if that's because there's some kind of broken trace under there. I really do question why they've done that. But yeah, it's like they've had the ribbon cable off on this side, but they haven't desoldered it properly and they've ripped that ribbon cable. It's obviously still making electrical connection, but it just tells me that whoever did the work on this camera needs some practice with using a soldering iron and needs to use better quality solder, because I can tell here that this is lead-free solder. It's very gray, it's very dull looking, it's very messy because it needs a very high melting point, and you can see where it's had to, it's kind of melted the Kapton on the side ribbon cable. As I said, it obviously still makes electrical connection, but it's just not a great job. The motor is insulated though, and it does seem that they've put new 3D printed motor mountings on, which is nice to see. What else? What else can I see here just on initial inspection? Not a lot. All right, so I said that one of the first things I wanted to do was figure out, is this going to be possible to PolaVolt mod this camera? And I'm going to show you guys. One of the things I want to demonstrate when I do these videos, I do want to show you guys a new method of PolaVolt modifying SX-70 cameras. I will likely do that in a separate video. Oh, I've also just noticed the plastic gear train here is missing a little lug on the side. That's supposed to have a little curved bit that then covers this screw. And that's snapped off, possibly because this ribbon cable is in the way. It's hard to know. But that's certainly snapped. Yeah, I want to show you guys eventually in another video a new way to PolaVolt modify these cameras without altering any of the ribbon cables. In my previous videos, it's got me snipping up, scraping traces. I've since rejigged everything and I figured out a new way to wire them in that doesn't involve any of that, and it keeps the ribbon cables completely intact. So the only modification to the camera really is that you drill a hole. So what I want to do, I've got my soldering iron nice and hot here. I'm just going to take the ribbon cable off. I'm gonna desolder this because there's so much blobby solder everywhere. And I don't like the quality of this solder, so I'm gonna remove it. And yeah, you can always tell when cheap solder's been used because it's very dull. When it's very dull, it has a high level of tin. And high levels of tin solder have a much higher melting point. Now when I do my projects, I use proper lead solder like they would have used back in the 1970s. This ribbon cable, by the way, is sitting too high. I think that's why that bit broke. Like, these pads are barely attached. They should be a little lower, something like that. I don't know if you guys can make that out. Now, a lot of you might be like, oh, well, lead is dangerous, isn't it? Aren't you inhaling lead fumes? Lead doesn't become a gas until something like 3,000 degrees. And if you're soldering with 3,000 degrees, you are doing something wrong. The fumes that get let off from solder are not metallic fumes or vapors, they are flux vapors. So lead solder is perfectly safe to work with. However, you shouldn't put it in your mouth, right? Lead only absorbs into the body really through like ingestion. Having it on your skin and stuff is fine. Where lead solder becomes a problem is if you handle a roll of this stuff all day long, and then you go and prepare your food and then you eat that. As long as you're washing your hands thoroughly, it's not really a problem. All right, what I want to show you guys is a little trick. So on the ribbon cable on the side here, the very front two connections, these two here, are responsible for dark slide ejection and the counter once it reaches 0 photos left. And what these normally do in a standard SX-70 is they tell the PCB up here there's either no film in the camera or the camera is out of film. And those traces, if we follow them, they go all the way here to the back counter. And they communicate with the counter. So if it's on empty, it tells the camera, oh, when fresh film is inserted, we need to eject the dark slide. And when the counter goes all the way to 0, another switch is engaged, and that tells the PCB, oh, we're out of film. And on a standard SX-70 PCB, what that actually does is it disables the PCB. It turns it into this like low power state, which doesn't fire the flash. And the reason that it does that is in case you had a flash bar there, it prevents it from blowing a flash. So if we cover those front two terminals up, I mean, we could cut the trace, right? But I don't want to commit to that just yet. So what I'm actually going to do, I'm going to use a piece of Kapton tape here, and I'm just going to completely seal off those front two terminals. I'm going to tuck that under the ribbon. So what I've just done here, I've insulated those front two connections. Can you see that? And I'm just going to wire on the remaining 5. So I am just going to I'm not going to do a good job soldering this. I'm literally just going to tack it in place. I just need it to be good enough to have a temporary electrical connection because I'm not putting this thing together yet. I'll add a bit of fresh solder since I took so much of it off. But yeah, so 2 things that I can tell from the soldering job. The iron that they used is way too hot, or likely had a tip that was too large and had too much thermal mass. And because they use very cheap, crappy quality solder, they burnt a lot of the ribbon cable. It's just not necessary. So I have very just tacked on here the 5 rear pins, and I've left the front 2. So what should happen now is when I insert a pack of film, there should be no dark slide eject. So let me just put the base of the camera back on. Oh, by the way, they've used a very sharp chisel to deskin this camera. Bit of a netty no-no. You shouldn't be leaving big gouges. Tells me that you're using the wrong tool. Come on, auto exposure, hello. Yeah, whenever I shine something that's very, very bright, the camera has a bit of a freak out. All right, so I am hoping that when I put this together very briefly and I put a pack of film in here, I hope that nothing happens. What I hope to see is the rear display turns on, gives me settings, but it doesn't eject the dark slide. Let's see. All right, display is turning on, and it looks like it's given me manual control. So let's try a full second. Beautiful. So it does seem that we're going to be able to PolaVolt this, because it seems like that dark slide is simply wired into the counter. It's not like hard coded into the firmware. One other problem that I wanted to point out is look at this autofocus. That is so slow. That tells me that the idler gears that go between the lens here and the autofocus assembly are gummed up, possibly with corrosion or just dust over time. This never should have been sent to the client. Like, this is nowhere near good enough condition. I want you guys to just compare that to this camera, which currently has its flash cam. This is one that I've just refurbished for a client. This is how fast it should be going. Can you guys see the difference there? Let me just take the batteries out. This one just has some epoxy on the cam follower assembly drying. That's why it's currently in pieces. Compare that to this. See what I mean? Like this camera just has not been serviced properly. But despite that, they've still put all the bells and whistles on in the PCB. And it's just like, no amount of improved technology is going to make up for a bad service. You know what I mean? This camera should not have gone to the client. It's in atrocious condition. All right, now one thing that I'm going to try, I have a old reservoir adapter here that long ago died. Someone left a comment on my video the other day asking about the reservoir adapters because they don't see them around much these days. I've done videos on these before. In my opinion, the electronics inside them were flawed. Most of them have ended up bricking themselves. The charging circuitry and stuff dies, and what I tended to find is they just refuse to turn on. But I kind of like the pogo pin style, so I wired in a little buck converter and an LED, and now I've just got a little portable power supply that I can use. So I'm just going to mimic having wired in a PolaVolt here. Still slow, but it does appear to turn on. So this is a good sign. So we have confirmed that my PolaVolt should be able to be wired in, and that means that I can get on with the rest of the disassembly and see exactly what we're working with here. So I'm going to take the side ribbon cable off again, and then I'm going to drop the shutter. So I'm going to undo the 4 screws. Now, when I drop the shutter in a second... Oh, I should also note, when I first got this camera, one of these screws was just put in loosely. It wasn't tightened all the way in. So I'm just going to take the 4 screws off. And then there's a ribbon cable that runs from the new shutter down and onto the little display with the buttons at the back that controls everything. Now, I believe that ribbon cable is attached to like a ZIF socket, and I should be able to just unplug it. I really hope that that's the case, otherwise this repair is going to become incredibly annoying. All right, let's drop that down. All right, now ZIF sockets, as cool as they are, can be very annoying because they tend to have like a variety of different ways to unclip them. Sometimes, like, they have a sliding bracket that moves like this, right? Other times it's like a little clip that flips up. They're all different and they all use different colors. Like, sometimes the bit you have to move is beige, sometimes it's black, sometimes it's blue. It's so irritating that they haven't just settled on a universal design. There's one next to it. Yeah, it looks like it just clips up. So, all right, we are out. And now we can have a look at the shutter. So, we have the Bluetooth module down the bottom. Look like we have a few capacitors and transistors, probably for powering the flash. Here, again, we can see the very average soldering job. Like, if I was this technician, what I would be doing is like get yourself a really good quality soldering iron, get yourself some good quality solder. I've said numerous times on this channel, I use Cardus quad eutectic solder, which is like a real, it's made in the USA. It is good lead-based solder. This is stuff used for like audiophile high-end turntables. The reason I use that is because every now and again I do refurbished turntables, and Cardus is a very well-known brand in the audiophile community. And if you can say to someone that a turntable has been refurbished using Cardus solder, it gives you some real brownie points in terms of being able to sell that turntable. Now, how much of that is nonsense? How much of that is branding? I don't really know. But to be honest, this stuff is really expensive. It is also really good. It's the best solder I've ever used. And even though it's expensive, it lasts a long time. So cost per use, I don't really give a toss, right? So even if a lot of it is just name brand, it helps me sell turntables when I fix them up, and whatever, that's good enough for me. But a good quality solder, good quality soldering iron doesn't have to be super expensive, but just one with a very thin tip and a variable temperature. Don't use those like all-in-one sticks that just heat up to like 8,000 degrees and burn everything. But yeah, if I was this technician, I would be getting good solder, a good soldering iron, and some practice soldering kits, because this just isn't up to scratch. This... And again, I'm going to take some photos so you guys can get a close-up, and hopefully I remember to actually post these, because I am famous for shooting B-roll and then never adding it into my videos. PCB says August 24th, so it's about a year old. But like I said, this is just... it was not done very well. And I'm gonna just desolder everything again. It's just it's just not up to scratch. Like, this is, in my opinion, this isn't acceptable if you're paying hundreds of US dollars or hundreds of British pounds, because these things are not cheap. I think they retailed for about 700, 800 US dollars. And for the quality of work, I would be very unhappy to find out that this is what my money was paying for. And like I said, it's not like this technician can't learn how to solder. I'm trying to do this in terms of like being educational here. I'm not trying to slander anyone. I'm just saying that like we should all try and do our best. And this just isn't, like, this is more of like an amateur grade of work. Like, let me put it this way. If one of my random followers were like, hey, look at this, I got this PCB and I installed it. This is like my first soldering project. What do you think? And like, you know, this was the first time they'd ever worked on a camera. I'd be like, not bad. Like, you know, everything seems to turn on. I think your soldering could be a bit neater, but you know, for a first attempt, good on you. Well, that would be one thing, but to pay a lot of money under the guise that this was professionally refurbished, that I'm not super convinced. As I said, either the technician needs to improve their skills, or this was a mistake and it was just hastily chucked together, like I just temporarily soldered on that wire over there. Maybe they were just very quickly soldering this together to test it, and then it got chucked in the finished pile. I don't know. But regardless, I'm desoldering everything because we're going to start all over again. I'm just going to take the front housing off. Now, as I said in the last video, this front housing is not original. It is 3D printed. Someone asked like if they could get access to the 3D printed files in my last video. Why? So you could have a subpar shonky quality 3D printed part that doesn't feel nice? Is that what you want? I will hopefully be able to find a replacement in my spare parts bin. This just doesn't feel great. It's not bad, but again, for the price, I'd be expecting something original, or at least like paint it, you know what I mean? It's no secret on this channel, I'm not a massive fan of 3D printed stuff, right? Because Generally, in my opinion, the quality, it's never going to be as good as ABS plastic. And so I think that 3D printing is cool for parts where otherwise you're never going to see them, or for parts where, you know, you can paint and finish it so it doesn't look 3D printed. I don't mind. And certainly, like I said, if it's an internal part that you're never going to see, whatever, 3D print away to your heart's content. But for a finished external product, I don't think it looks professional enough, and I see a lot of 3D printed people, a lot of people into the 3D printing scene make stuff and show it off, and I just never think that it looks good. And I don't like seeing people pay like a fortune for something with low quality parts. So I will be putting this off to the side, and I will continue focusing on the rest of this. Okay, cool, it's got no screws up in there, that's good. And we'll take the front housing off as well. One other thing that I'm gonna do here is this camera still has its helper light circuit soldered in. In fact, it appears that Dan has designed the PCB in such a way that you leave that part plugged in. For those that don't know, the helper circuit is like this little tiny daughter board here. It contains an LED and a little light sensor. And what it does is it tells you when you're using SX-70 speed film whether or not your photo is going to have camera shake or not. It shines a little LED through the viewfinder, and it'll be red if it thinks that your exposure will be too long, right? I'm going to remove it here, and I'm going to remove it for two reasons. The first being that, well, this camera doesn't really take SX-70 film anymore. It takes 600 film by default. And the second reason I'm going to remove it is I want this camera to have as much access to power as possible. It's already got a brand new PCB with its own little microcontroller and its own little CPU. It already has autofocus, which takes power. It runs 2 motors. It has the display to power. It has the motor to power. It's got a lot of jobs. I don't think it needs to be wasting extra electricity on an LED that doesn't actually serve a function for the most part. So I will remove this. Polaroid themselves, by the way, deleted many of these LEDs off of the later model SX-70 sonars, especially in Europe. It's very, very common to find sonars sold in Europe that just simply don't have that part. And as I said, because this camera doesn't expose properly, you know, the shots taken at 1/4000th of a second, for example, were totally blank. I want to rule out that being a power issue, and I know this little circuit isn't going to be drawing too much power, but I don't really care. I just don't want anything unnecessary sucking juice that's not meant to. So we'll put that to the side. I'll just cut the little pin there, and we can now just remove this. And this bit also gets removed when I do SX-70R conversions. Okay. So that's what that little board looks like. Now I'll give this back to the client. I mean, we could always reinstall it in the future, but I think personally, given how the camera functions, I want to give this thing every bit of a fighting chance to work as good as possible. And as I said, unless that part has had its resistor replaced to a different value, this isn't even going to be calibrated for the right speed of film. So we might as well just ignore it. All right, I'll put that light dark wheel back on for now. What I'll likely do, I'm not sure if I'll do it on camera or off camera, but I certainly need to do something about that. The whole idler gear system here, it is just, it's really stiff. It could be that the motor needs replacing. I'm not entirely sure yet. I want to say that more than likely the idler gears here, this one and this one here, like this one and this one, are probably all gummed up with corrosion and need to either be lubricated or just flushed and cleaned out. I'll probably do that off camera. Or as part of a montage, I don't know, I haven't decided yet. I want to keep investigating the body though before I dive any deeper. I will just quickly resolder the rest of the ribbon cables on here though. The main thing I need to adjust is the solenoid here, but I will also redo this because the ribbon cables, like I said, they're not up to my standard at least. Maybe it's up to this person's standard, but our standards, we are not the same. And I know I harp on a lot about soldering on this channel, because one of my pet peeves is seeing solder that's like low quality or very messy. And I know that there will be some people in the comment section that go, well, why are you spending like so much time harping on about solder? Like, truthfully, it doesn't really matter as long as the electrical connection's there. You know, as long as the camera functions, as long as the circuit is complete, like, why do you care so much? My answer to that is like twofold. I've also noticed the tab that goes on here has been broken, so it's like only solder holding that together. Man, this thing was really butchered, hey? There's also a little solder burn on the back housing here. But yeah, it's really the principle. If you're gonna do a job for a client, do it as neat as you can do it. Because honestly, the difference between doing a neat job of soldering and doing a messy job is quite literally like seconds. It's not that big a time difference. It's not like a technician's like, oh, if I did it neat, it would take me 6 hours. No. If you did a neat job, it would take you a minute instead of 45 seconds. You know what I mean? Like, it's not that hard to take a bit of pride in your work and just do a neat job. The other thing that doing a neat job does is helps you with troubleshooting, right? There's nothing worse than having a problem with a camera and like you open it up and it's a dog's breakfast in there in terms of soldering. Everything's messy and you're thinking, oh, the issue could be just about anything. All right. Cool. Just trying to get rid of all the original solder that's on the back of this ribbon cable. I'm just gonna get a bit of card like that so I can get my solder wick here. But yeah, my dad taught me at a very young age, like if a job's worth doing, it's worth doing well. And I think that's just such a truism. Like, just do your best. Always. Don't half-ass things, because when you do a messy job or a subpar job, it only makes your future work harder. You know what I mean? Like, sometimes an extra 1 minute of work can save you 2 hours of troubleshooting. That's my philosophy anyway. It's like the old proverb. I think it's I forget what country the proverb is from, but, you know, if you've only got 5 minutes to chop down a tree, maybe spend the first 4 minutes sharpening the axe. You get what I'm trying to say here? You guys understand? Like, don't cut corners early on because you think it's going to save you time, because quite often that's only going to result in you having to do things all over again. All right. You know what? While I'm here, I'm just going to desolder the main solenoid because I am going to move it. Actually, let's even see if it needs to be moved. So, to work out the solenoid position, there's a little screw here, right? So when you desolder the legs from the solenoid off the back of the PCB, it's got an oval-shaped hole that when you adjust that screw, it lets you slide it backwards and forwards, and that changes the position of the solenoid where the blades close. Now, if you have a look very carefully down here, there's a little spring, right? Now this spring is present on alpha or sonar style cameras. This is going to be a little bit different in Model 1 cameras, but because Model 1 cameras have an extra switch, you'll see if you've got one in front of you. But what you want is when the solenoid gets plunged, as it touches that spring, there should be a tiny little square-shaped opening. And on this one, it's completely closed. So I need to actually move the solenoid so that it's in a consistent position. And if that position is not consistent, it's going to throw off all the manual timings. This is what I'm talking about here. You can't just slap a new board in one of these things and expect it to come back to life and be amazing. So I'm going to take out this screw for the solenoid here, and I'm going to put a little plastic washer okay, because that's going to help the solenoid stay in whatever position I tighten it to. If you don't have the washer, it tends to kind of, as the screw binds up to the plastic, the solenoid moves itself and knocks itself out of alignment. So what I'm going to do here is get the solenoid to a position that when that little plunger hits the spring, there's a tiny little square hole. That's what I want to see. Needs a little bit more. Give myself a bit of extra light here. Great. So, maybe if I, where'd that white bit of card go? Maybe if I try and line it up, as I'm closing the blades, as they touch the spring, there's a tiny little square aperture hole. Can you see that? And then as the blades close all the way, engaging that secondary spring, the blades are completely closed. So that is effectively like factory solenoid position. It's not always the case in alpha and sonar cameras that it is in that position. Sometimes it is, sometimes it isn't. And the truth of the matter, it doesn't really matter on automatic speeds, but it does matter on manual speeds when you manually time the camera. That is my understanding with like Mint cameras, the SX-70R project, Open SX-70. I can only assume that it's the same for this. If it's not, well, I'm going to be here for a long time doing trial and error. So I'm just using my soldering iron to bend back the legs on that solenoid. And now I will resolder it in place. Get a bit of alcohol and a Q-tip and just clean off all the flux I've been leaving behind. And then what I'm going to do, I'm just going to grab some contact cleaner. I mean, this solenoid does seem to be in fairly decent condition. It moves fast. I am just going to get a bit of contact cleaner though and spray the piston. I mean, this looks really clean, but while I've got it apart, I'm just going to give it some exercise. Now I still have work to do on this shutter. I've obviously got to fix that autofocus assembly, which is just, like, it just sounds so tired. I've got to resolder this ribbon cable back on properly. I've got to put this ribbon cable back on. I also have to cut this glass out and clean the fungus, because there is actually fungus inside this thing. But I want to move away from the shutter and just keep focusing on the body. Alright, I'm just looking at how the ribbon cable is routed. I'm just going to remove this Kapton tape because I think that's going to be annoying. And it looks like the ribbon cable routes right through the middle of the hinge. I'm showing you guys at home because this is the first time I'm ever seeing one of these cameras. And so everything that I'm witnessing here is like reverse engineering. I've never seen these before, so I have to pay particular attention on how things are held together. I am very curious as to why that ribbon has been scraped, by the way. I haven't forgotten about that. All right. And yeah, here we can see where the ribbon cable travels. Oh, that's cute. It even presses into the viewfinder there. I think the viewfinder is like one of the few things I don't have to do much to because it is actually pretty clean. The rest of the camera isn't. This is a surefire way to tell that the viewfinder has never been taken off. When the bellows are dirty up here, that tells you that the camera's never been taken apart to be cleaned properly. They've cleaned the sides, but not this part of the bellows. Again, it's a bit of a netty no-no. I think it could have been done a lot better. I am going to leave this part attached up here because the ribbon cable then goes into the sticker. Now, fortunately, when it comes to doing the rest of the camera, I can disassemble and check the Fresnel screen without this part needing to be removed, and I can do the rest of the viewfinder cleaning without the hinge pins. But if I take these hinge pins out next and remove the viewfinder, I'm going to have to deal with routing that ribbon cable, and I just don't want to. So let's collapse this down, and I'm going to take this thing apart further. Take one hinge pin out, which was actually loose already. Again, not a great sign. Now, using the square-headed screwdriver, I will take out the two fine square-headed screws. Same thing here. Great. I'm just keeping them all in a little lid off to the side here. Oh, one thing that I'm going to do, since we're modifying this to I-type film, I do have to remove the little metal tongue. There's a metal tongue inside the film chamber that prevents you from inserting what Polaroid deemed the wrong type of film. And Polaroid frustratingly put a weird little lug on their packs of film to prevent you from inserting I-type film. So we'll take that off, and I'm just going to grab a little file, and I'm going to file down the two little stakes that hold that bit in. And don't worry about the dust, we will be cleaning this in just a second. I just want to do this now before I forget. I'm kind of doing everything here in a bit of a weird order for the sake of the video. Nearly done. All right. 44 minutes in. Still taking this thing apart. Okay. So hinges are out. Next thing I'm going to do is slide the erection arm post out of its rail. Pop that there. Now I've got my special bendy screwdriver to undo the bellows clips. now we get to have a look inside the camera. Now the Fresnel screen is in pretty decent condition. Big thumbprint on the mirror. I'll clean that off in a second. We'll pop that up. Just adjust the little metal baffle. Big thumbprint on the mirror here too. So that definitely needs to be cleaned because that will show up on the photos. All right, now since I've confirmed that we can in fact PolaVolt this camera, my new method of doing this, I'm going to reach inside and I'm going to snap off the little brass posts, the battery terminals inside the camera, because we will not need those anymore. Okay. The next thing that I'm going to do, the tripod socket inside here has like, and it's not on all of them, but on some sonars, it has these like 3 little rivets. The one that's at the front, I'm going to file off with a Dremel because that contacts that notch on the I-type film, and again, it makes it hard to insert. If I quickly just remove that, then we don't have anything to worry about. Then what I'm going to do, because it's going to make a bunch of metal dust, I'm going to take this camera outside, blow it out with a leaf blower, and clean the bellows, because we can see the bellows inside are really, really filthy. Both mirrors have fingerprints on them. Everything's just very, very grubby. I'm going to give that a clean, and I'm going to do that off camera because literally you guys know what a cloth and Windex is, so there's no need for me to show that. I always get asked what I use to clean. Just glass cleaner. Glass cleaner is really good for the rubber as well. You should not use any heavy solvents on the rubber because it will dissolve otherwise. So I will just quickly use the Dremel. Let's turn on my power. I keep it always hooked up for this very reason. I'm going to reach inside. And that's it. I literally just want to file that front lug off. It's going to make inserting I-type film a lot easier. So I'm going to pause the camera. I'm going to come and clean everything, and I'll be right back, okay? All right, I'm back after cleaning the bellows and both mirrors and the optical assembly and the viewfinder and the Fresnel screen. And the last thing that I want to do on this video before I start to tackle the PolaVolt, which I'll do in its own separate video, is I want to install a new motor. Now the motor that I've chosen is a slightly slower motor than what's otherwise currently in the camera. Those that have seen my videos on the subject of motors before will know that I have 2 brand new Mabuchi motors that I generally install into clients' cameras. The first is this 16,000 RPM motor. The second is a 20,000 RPM motor. 20,000 RPM is obviously much faster. I have a lot of clients that really like the faster ejection speed. The 16,000 RPM motor is obviously slower, but it's better on cameras that are older, such as SX-70 Model 1s, which tend to have more fragile gear trains, so it's a bit less stress. I like to use the slightly slower motors for, better potential longevity of the camera. Alpha and sonars tended to have stronger gears, so it's not really a problem. It's very uncommon for a sonar camera to strip a gear, for example. However, there is another reason why I'm going to use a slightly slower motor in this camera, and that is to save power. Simply put, hold that thought while I receive a package. Well, that was good timing, just an order from RS Components of new capacitors. As I was saying, the reason that I'm going to use this motor is because the slower 16,000 RPM motors draw less power. This motor draws far less amps than the stock motor and the 20,000 RPM motors, and that is going to help in regards to this camera. As I said, the fact that some functions didn't work properly, I want to absolutely rule out that it's not a power supply issue. Brand new PCBs, because they are digital and have their own little microprocessors and stuff, tend to be more power hungry than the stock PCBs. And when you combine that with a sonar camera that has to have a high voltage transformer and an autofocus motor and sonar transducer and all the extra little bits and pieces, I want to make sure that Dan's invention here has as much power as it can possibly give. You know what I mean? Like, I don't want to put like a very, very fast motor in this, because this camera still has its stock motor. I don't want to do that and find that, you know, the high current draw takes power away from the display or interferes with the CPU. Because I don't know how much draw each of those components has, that's why I'm going for such a paranoid power-saving model here, because I absolutely don't want that to be the case. So, I am going to take out the original motor here. I'm also going to take out the little 3D printed rings that the motor sits in. I am going to remove the Kapton tape and also just inspect. I'm going to inspect why there's been scrapes made at this trace. I'm very curious to see what I'm going to find under here. I'm not seeing a lot. I'm seeing that the driver chip has probably been replaced at some stage. I don't know why this part's been scraped off though. So that's a bit of a mystery to me. It does seem like this driver chip works though. What I might just quickly do is add a bit of my fresh, proper lead solder. Just to make sure that that's getting a good connection there, and then I think we can safely put this back. Once I get this Kapton tape off. But yeah, I don't know why they have opted to... Gee, this Kapton's sticky. I don't know why they've opted to scrape away at that trace there. It's a bit of an odd one. Oh, this is really sticky. Okay. That's off. I'll put my own Kapton tape on that in just a second. But what I want to do is just remove the motor, because we're not going to use the original. I'm going to put the brand new one in. Now when I say that the 16,000 RPM motor is slower, it's not ridiculously slow. It ejects about the same speed as a brand new Polaroid i2. So the key is that when you have ejection, you want it to be as steady and as smooth as possible. And that's why I opt these days to put a new motor in every single camera that I refurbish, whether it's 16,000 or 20,000 RPM, I don't really care, as long as it gets a new motor, because I don't find any difference in performance other than the speed between the two. It's not like one of them spreads the developer chemicals more evenly than the other. I don't think speed is the issue. I think it's consistency and smoothness. Because I get asked a lot, like, oh, does your 20,000 RPM motor spread the developing chemicals better? No, I don't think so. I think the big difference really is the smoothness. That's the main thing. So, my new Mabuchi motors need to be adapted, so I've got a little piece of 6mm tube that I'm going to put on that. In fact, I'm not going to recycle this. I'm going to keep the front 3D printed part, but I'm not going to keep the rear. I'm actually just going to cut another piece of that 6mm tube, because it's going to fit better, I think. And then I'm going to put the new motor in. Now this new motor, they come from the factory without the correct fittings. So you guys can see I've added wires, because they use these like horizontally opposed positive and negative, red being positive, the other side being negative. I need to route wires in order to connect them to the pads there. So that's why I've already prepared this one. I generally prepare all my motors in advance. And then the last thing that we need to do, I need to stretch the spring a little bit. And I also need to crimp the rear of this spring, because the new Mabuchi motors, the shaft is quite a bit smaller than the factory original. So it does need to be crimped in order to be pressure fit. I'm just going to crimp that a little bit more. In order to be pressure fit onto the new shaft. Alright, that should do it. There we go. Now, that spring is held in place nicely. So, I'm going to tuck everything in, and I'm going to install the new motor. Tuck the spring in. Find my little bendy screwdriver, because what I need to do next is get the spring onto the drive shaft. Seems that that spring was already pretty stretched from the last technician, so I'm just going to compress it a little bit again. To make my life a bit easier. Put it back on. Take two. The sonar has a really long drive shaft. Getting the spring on is a little bit fiddly. This is like, this part could be one of the hardest things about restorations. There we go, that's on. And then while I've done that, I'm just going to lubricate the gears, because I know none of this has been lubricated. I do 2 lots of lubrication these days. The first lubrication I do is a very thin oil on the axles for the gears, and then I use a plastic grease for the actual cog surface. That makes the gears much smoother, and it makes the ejection a little bit nicer. All right, let's collapse that down, and now I can put the Kapton tape and stuff back in place. I'm going to tape that part down. Where is my Kapton tape? Here we go. I'm just going to cut myself a few pieces. Alright. Let's take contact here. Cover up that bit that was, yeah, for some reason scraped away. And I'm also going to put a piece of Kapton tape on the motor. You guys will see why in just a second, and that's because this ribbon is now going to sit on top of that, and I don't want anything short-circuiting. All right, so just need to poke my wires a little bit better. There we go. All right, now I can route and trim those wires. Before I do that though, I just want to install, I have here a little 1 microfarad capacitor. I'm just going to put that in between positive and negative on the motor here. And again, the reason that I'm doing this, that adds a little bit of voltage smoothing for the motor itself, and that's going to hopefully help with any kind of motor noise or DC ripple that could interfere with the way that the PCB works. As I said, I don't really know how isolated the PCB is or how susceptible it is to noise. It seems to work completely fine powered off of I-type adapters, but being that I-type adapters use switching power converters, I want this thing to be able to run off pretty much everything. So you guys are seeing steps here that I would not normally take on refurbishing a standard SX-70 camera, and that is because I don't know anything about Dan's PCB. I don't know its tolerances. I've never used one before, and I really want to rule out voltage ripple or a lack of power causing issues, especially given the dud exposures that I got, because the overexposed photos, those are probably caused by the solenoid being not adjusted properly, but there were a few blank frames that I got, just completely blank when the shutter was set to above 1/4000th of a second, and that might be due to some kind of power failure, maybe the electric eye failing or something like that, and I just want to make sure that power-related issues are not a problem, because there's nothing worse than troubleshooting for ages and ages and ages only to find out it's like your I-type adapter that's the problem. And like I said, my I-type adapters, my PolaVolt, is very good, but I've never tested it on this PCB before other than very brief bench tests. So any kind of smoothing I can give this thing, I want it to have the best fighting chance. Alright, so we have a 1 microfarad smoothing capacitor, positive and negative hooked up, drive shaft is hooked up, and the last thing I'm going to do is just insulate the bottom of that. And then I'm going to pause this video and resume at a later stage. So we have a body that is now, for all intents and purposes, prepared, ready to have its shutter resoldered, reinstalled, and ready to have the PolaVolt I-type solution that I came up with installed. One last thing I'll do, you remember those ribbon cables on the side? I said they weren't soldered very well. I will just add a little bit of solder just to make sure everything is good. But yeah, I want to say that maybe the history of this camera, it had maybe a dead motor chip, or maybe the ribbon was in bad shape or something like that. So the previous technician has removed the bottom ribbons and soldered in a new driver chip, and they've damaged the ribbons a little bit on the way. But it works okay, so here we go. That's there, and I should be able to attach the door. Cool. Alright, that about does it for this video. Stay tuned for the next part where I will show you my new technique in terms of wiring up the PolaVolt. And yeah, then we're going to do another one on the actual shutter assembly, getting that working, and hopefully I'll be able to do a proper review. Thank you so much for watching. I will see you guys in the next video. Remember to like and subscribe and all that junk. Feel free to send a donation through the links below if you like what it is that I do. I would normally say send me something to repair, but at the moment I am fully at capacity, probably until August or September later in the year. So I just wanted to express my thanks to everyone that sent me something to repair. I literally wouldn't have a job without you guys, so thank you so much for all of your support going forwards, and yeah, I will see you in the next video. Bye!